we don't just keep making the same locks over and over again. We're constantly trying to make improvements to what we have, trying to make them a little bit better.
Well, as a lock assembler for you, when Jim came out with the Golden Age tumbler, I immediately saw that this is for the better. But when we're building the lock, that one single change created other mechanical problems that had to be dealt with and had to bring those into alignment. And one is because the radius or the cam race equates to a stirrup lock, the mainspring had to function not differently because it's got a certain job to do, but it had to function in a different place to get the power and the speed. And so we had to move the springing one half of a pinhole toward, now the pin being the anchor pin on the spring, toward the center of the tumbler to take advantage of the mechanical advantage that was built into that tumbler. But now when we did that, we gained speed. What is speed? Well, in this sense, we're going to use the analogy of a compound bow. You know that funny contraption with training wheels on either end? That is a marvelous piece of engineering in that it is the epitome of mechanical advantage on arcs. And it's got all of its power on the bottom. It cams over and goes what we call soft or easy. But when that arrow is released, it gains speed all the way to battery. So too does a late English lock. It's very soft on top. I mean, your hand will almost come off the top. You say, well, why'd that happen? But as that thing fires, if the timing of the frizzen is in relationship to the edge of the flint, when the flint has no need of the steel, they should both terminate. And the frizzen should not reverberate and come back. Well, the Golden Age tumbler will give you the speed on the bottom. Another analogy for a mental picture, one of the worst springings that you can imagine, and I'll just use the name, is a Thompson Center coil spring. Now, a coil spring's got all of its power when it's bunched. It has no power when it's extended. Well, during the battery operation of the lock, it goes from all of its power to none. And people say, well, that thing blew my hammer back to half cock. 2 points that I see there. One, he had too much powder, and the other is that he did not have the springing pressure to hold the hammer on the cap. Well, on the flintlock, if one times that frizzen, that it will activate. On a frizzen, you're going from standing still to an 8-ball cue ball. And when that thing gets battered, it's going to move forward a fraction, and then the spring says, I'm not going, smack. You'll see two score lines in the frizzen face. All right, the momentum is now on the side of the hammer, and it will drive it over the cam, and at the instant that the alignment of the axles come up, where the flint is through with the frizzen face, it ought to cam over. So, back to your question there, when you change that tumbler, you increased the speed of your lock once we attended to the offset that was imparted because of that single change in geometry.
Would you agree that with the flintlock that I think personally that the breaching of the flintlock has much or more to do with how fast the gun goes off?
With the caveat that the lock has to be reliable in igniting the powder.
That's
right. Yeah. Oh, yeah. But you got to have that, like Wallace talked earlier about the big heavy locks being very reliable. Now, I'm not saying smaller ones aren't if they're done right, but so okay, we got that. Now, you need that inside cone on the touch hole, and that, I believe, what gives you a great deal of speed when the gun goes off. Yeah. If you don't have that, you're going to get a slow ignition burn. This was something that Linton McKenzie, who had a lot of experience with high-quality flintlocks, preached to us years ago. And I dragged my feet for quite a while trying to cut the kind of touch hole configuration that he said was best. And when a customer twisted my arm hard enough and said, yeah, you got to do this, I did it, and I was just astounded. at the difference in consistency and speed that we got from this larger cone type touch hole. Linton called it a sharp touch hole.
Yeah.
Now I don't know what they called it in the 18th century, unfortunately, but it's the kind where the cone, I think of it as kind of a conical bullet shape, comes right up to the touch hole, close to the edge of the barrel. So you have very little wall thickness, but that wall thickness, as you move away from the outside edge of the barrel, very quickly thickens up. So you've got some meat there to keep it from burning out and blowing out. You can't just take a regular drill shape, drill into that touch hole liner, bring it that close out to the barrel because there's no strength there, and you'll blow it out in one shot. Okay.
Well, I mean, put it another way, I think it's better to bring powder to the fire than the fire to the powder. I mean, the more
No, I think it's better to bring the powder out to the pan. Okay.
well, that's what I'm saying.
Yeah, right. Rather than cutting a countersink of some kind,
absolutely.
I don't think you want to do that.
No, that's
I
what
mean,
I'm
you
saying.
think, well, maybe you could do that, but I don't think it'll work quite as well. And one of the reasons, I think you can look at just the fact that that's the way they did it in the 18th century. And that may sound, I don't know, naive or maybe lacking in experimentation or something, but they did this stuff for a reason, okay? And they experimented with it a lot. And if you're going to build a piece today, you ought to pay an awful lot of attention to what they were doing. They worked this stuff out, and they had to have it right. Somebody here was saying earlier about the competition level between gunmakers in the 18th century. It was extremely fierce. And they did everything. Look at the lengths they went to, which in London, trying to during this whole period of improved locks. It seemed like every 20 minutes there was some kind of new silly improvement. My mind silly coming out that didn't really change the basic the speed of the locks. When they had gotten to a certain point, they'd worked the springs out, they'd gotten the size down, they'd worked all these patent breaches and things like that out, and they'd made some big improvements. Then they kept hanging other things on there that I have a bit of doubts about, gravitating this and all kinds of strange things that don't interest me a whole lot. But it's that breech form that they really worked with, and I think it made a big difference. And in my experience, that one touch hole form is really important. Now, recently, my friend Tom Snyder over here made up an inside coning tool for doing a touch hole. And now I generally use Jim's touch hole liners, these White Lightning touch hole liners. I think super. But David Wright, the artist, last year or a couple of years ago at the CLA show said, "Mark, tell me why do we go ahead and put these stainless steel liners in these authentic 18th century style guns?" I said, yeah, good point. And so I've been kicking that around in my mind and trying to find a way to cone those things from the inside and just see how it worked. And maybe over a period of a couple of different rifles, get some experience, not only see how well coning them from the inside works, but how quickly they burn out, too. That's a big issue. The stainless steel is going to stand up a lot better to heat erosion than regular barrel steel.
Yeah, I borrowed one of Jim's White Lightning things and copied the profile of the inside.
Yeah. Oh yeah, it's a good profile. It doesn't get better than that. But so Tom made this thing up with a handmade cutter. It's cut like the same way a bullet cherry is cut. You can cut it with file it out, and these things cut beautifully. They are smooth as glass. They don't cut real fast because you don't have a lot of chip clearance. So anyway, we put this in there and cut it out, and it cuts just a beautiful recess. And I'm starting to shoot that now, and I haven't had a lot of experience with it yet, but it seems to work as well as the normal chamber does. I haven't seen any evidence yet of heat erosion, but I haven't been able to shoot it a lot. It's a new gun. I probably don't have 20, 30 rounds through it. Okay, and that's really not enough to tell yet. Now, during the 18th century, we know they coned like this, or they coned them out on the inside. Okay? If it did burn out quick, they bushed these things. And most of the bushings I've seen are smaller diameter than the larger touch hole liners we put in today. If a gunmaker bushed a touch hole for a client, and he had a inside coning tool of some type, I think he could easily go back in there, bush it back in there, recone the thing out, cone out the portion that he replaced. And this was something I think probably was done reasonably often. The same way with re-steeling a frizzen. Now, when I talk about re-steeling a frizzen, I'm not talking about re-soling a frizzen. Okay? That's a different thing. The other process is re-hardening the frizzen, re-case hardening the frizzen. And I'm sure many of you know that during the 18th century, lock parts, the frizzen in particular, made out of wrought iron, was pack hardened in charcoal of some kind, and that imparted the high carbon in the surface, and then it was quenched in water so that it was hard and spark. You can cut, depending on how long you cook that frizzen at critical temperature, that determines the amount of depth you have and how much wear you're going to get out of that frizzen. Eventually, you're going to cut through it. Okay? If you take that frizzen, repack it in charcoal, heat it up, soak it for a little while, and then quench it, you have added steel back to where you had clawed it off. Okay? That's a pretty easy process to do compared to resoling one. Because I think they did these things, this was standard maintenance, that they could carry out pretty easy. Any gunmaker, probably any blacksmith. Many blacksmiths could do that. This is not a high-tech kind of thing. Okay?
Do you find that coning a touch hole from the inside facilitates self-cleaning during gas being expelled?
I have found that that form, whether it's created by a touch hole liner or by you just coning it out from the inside, generally stays cleaner. Now, you can always get that odd flake that falls in there and blocks things up, but generally it stays cleaner. Now, for example, the first one I ever did, I think Bob Harn was the first one that made one of these things up, and we talked about it. The same client harassed me, and I did it, and I made one up by hand. First, it was probably the second one that had been done, and I put it in, went out and tried it. Well, I wanted to see how this thing looked and how it really worked. So I went out, sighted the gun in, like the way I normally would, except I didn't clean between shots, and I stopped after about 15 shots, went home, hadn't put a patch down the bore, pulled the breech. So I wanted to see what it looks like dirty. And when I pulled that out, I was astounded at how relatively clean that touch hole liner was. What I saw was the majority of that touch hole liner, majority of this curve in there was just kind of a gray color. And there was a little ring right around the periphery, kind of where it joined the barrel, and it was a built-up ring of carbon in there. But it occluded a relatively small volume of that. Even in that occluded state, that hole was appreciably larger than a standard touch hole liner that we were using before. So I was really surprised how well that essentially self-cleaned,
Well, how about the fouling that builds up from your breech plug? Because you've got, eventually that's going to come right up and start covering that.
Yeah, that's not going to change, and I think a scraper is probably if you're not able to flush the bore out by putting it in a bucket of water or using one of these tube things, you got to clean that out with a scraper.
Well, that's why I like that modified knock breech. I just think that's the way to go. I mean, I've been shooting a gun, and you can shoot all day, whereas if you got a standard breech plug, after about 25 shots, it's gonna get slower,
Yep.
and you gotta get that and grind that stuff
Yeah.
off the face of the
Yeah.
plate. Whereas with a modified knock, you don't have to do that.
Yeah. Can't use a knock breech in an authentic long rifle.
Well, you can, sure you can.
Well, all right. Let me rephrase that. I don't think you should.
You can do it so you can't tell it.
Yeah, but I still don't think you should. I mean, yes.
That you were talking about corrosion in the touch hole. What are thoughts you all have on the modern powders now that are non-corrosive? Are there any opinion on 777, American Pioneer? What's
Anybody
the
have any
consensus?
experience with that? I don't.
Well, if you don't clean Paradex, you've lost the barrel.
Beg your pardon?
If you don't clean after using Paradex, you have lost the barrel.
Well, now, the 777 you're talking about?
No, this is Paradex. The only experience I have with 777 is in 45 long coats and in 45 70s. Velocity suffers somewhat. You got to have a hotter ignition system. The primer has to be hotter, but it'll clean up with water. But you can go for long periods without any corrosion with 777. But that's the only one I have experience
I
with.
just read an article on American Pioneer which said they can shoot 2,000 shots without cleaning, no fouling.
I don't have enough money to shoot a 45 70.
No,
That's tough to believe, isn't it?
I didn't know. Well, it's
I don't-
sold in Walmart. It's sold all over.
I don't know.
Good point.
Igniting a
came
flint
in the
gun?
shop a couple of weeks
Igniting a
ago,
flint gun?
and he was complaining because his gun was a little bit slow. And I asked him what powder he was using. And he said, well, I've been using black powder cartridge powder. I said, well, do you have some on it? He said, yeah. I said, with the lock out of the gun, I said, let's try it. So we primed that lock and tripped the sear, noticed how it went off. I got some regular black powder and put in, and visually you could instantly see the difference in how quick that regular black powder went off as compared with the rifle cartridge powder. So there was a big difference. Getting back to the touch hole thing, let me elaborate a little bit on that. Linton McKenzie's the one that started this whole thing, as Mark said, standing right here. Now, he was standing right there and drew all kind of pictures and lectured on this. And Bob and Mark started making some of these, and then they conned me into paying for the tooling to actually produce these things, so they wouldn't have to do it one at a time.
Right.
So that's how how I got into the touch hole business. But if you have objection to the stainless steel color, we've never advertised this, and darn few people know about it until right now. But we do make those out of 12L14. You can put them in the barrel, and they just blue, brown, whatever. I can't guarantee you'll get more than 100 or so shots out of it, but a lot of guns are not shot any more than that.
You didn't even tell me about that.
No, they didn't tell Mark about it.
Jim, isn't that stainless steel just platinum?
Well, yeah.
Platinum they didn't start using that till 1805.
But does everybody know that? You don't.
I'm doing my best.
Mark, we strive to, breach square bottom gas seal, but yet we'll drill into the side of it, for our touch holes, which exposes both sets of threads to fouling. Does that affect longevity of the breech plug?
You would think that, ultimately it would, but in a practical sense, I don't think it's a big problem. Again, we're still talking about looking at relatively small numbers from a statistical standpoint of these things, but I haven't seen it be much of a problem in the 30 years that I've been. If I can avoid that, I try to. I can't always, depending on the style of a piece, the shape of the lock, so forth.
Well, if you put a white lightning in there, do you go far enough forward of the breech plug to try to miss, to only come out on its face and miss the thread?
If I can, but it doesn't always
But it
work
doesn't
that
always
way.
work.
And you're not talking about a huge difference in diameter, effective diameter there. I'm trying to think. I think you can go into that area a little bit, and I know this is a touchy subject, but what the heck?
Lawyers.
Well, Elsie, do you want to describe the problems we've run into lately on touch hole liners hitting breech plug faces and
Yeah.
it causes when you back that breech plug out?
Okay. Keep your train of thought,
Yeah,
because
yeah.
Not
that's
to
good.
stop you,
Yeah.
Mark, but to give them a reference point from what we've seen coming in lately
Well, several things on breech plugs, and we have a caveat in our literature that if you on how to remove a breech plug. Now, you would think a gun builder would have to be cautious on how to take a damn breech plug out, but you do. There's generally not much more than 1/8 of an inch of wall thickness on a barrel on the wall that connects the breech plug threads. So if one puts the breech of a barrel in a vise very near the breech and squeezes, and in a tapered barrel, you're putting a lot of single point pressure against the barrel, pinching the barrel against the breech plug. Boogers. Now, you're going to try to force that out, and it is now elliptical. And so it's going to try to cut or gall as it comes out. But even though we recommend they step 1 inch ahead of the plug to preclude that, when they're actually installing the touch hole liners, they are nicking the breech plug. In other words, they don't remove the plug to install the liner. All right, anytime a twist drill goes through, we're going to have a burr. If that drill touches that inner piece of steel, which is the face of the breech plug or the breech plug threads, now you've got 2 burrs, and they're going to interlock. All right, they'll put the touch hole liner in it, go on with the gun, and find out, well, I've got cleaning trouble. So they'll try to remove the plug with the touch hole liner in place. There's 2 threads missing off the end of your plug if you do succeed getting a dead burn thing out. And so now we're having to educate throughout literature to go ahead.
Yeah, I want to make the comment that when you put in a touch hole liner, you don't ever put it in with the breech plug in. Ever. Pull the breech plug out, set up, you're drilling and tapping, deburr the thing, and before you put the breech plug back in, you radius, where your threads go through, and where that plug intersects with the bore, you need to get in there and round these surfaces off so that you don't have corners and recesses that are going to hold fouling any more than absolutely possible. You go in there and you need to work all that stuff off. Now, I hate to use this word, but the best way to do that is with some kind of rotary tool. Some people you know that as a Dremel tool. I don't have a Dremel tool, but I got a Fordham. Okay, and I got a little ball-shaped burr. I've got a burr and I've got a stone. So I got a lot of metal to remove. I get in there and very carefully I set that thing up at an angle and vise shine my light down in there and get in there and work that stuff out and round it out so you don't have any corners and recesses and burrs. Okay? And then I go in there with the stone and just polish it up a little bit so it's not too rough. It's still not a perfect solution, but it's I think the best way to approach that.
I agree with that. I think in ages gone by, the powder was probably not as potent as it is today, but that's only speculation. And in fact, we probably use more than we should. But if one looks at a lot of original plugs, they were not as deep as we put them in today, and they were tapered in many cases. And when one breaks an original plug loose, assuming that everything being equal and it was a fresh fit, not galled and fouled and a century of accumulation in there, if you could break that plug free, it would immediately wobble in the threads because it's a pipe taper type thing. You just thread it out with your fingers. Well, we don't do that today. We use cylinder type threads and V threads at that. And if you do time it properly, where it's gas seals on the shoulder, now we're not talking about going into that barrel setting in breech plugs with a 118 degree twist drill like some people do. That really should be square shoulder in there. And if you time it to where the plug depth is going to gas seal at the very instant that the top of the tang times on the top flat, there will be a slight semicircle burr roll up because of the tube material starting to gall. And that can cause, if you don't take all this off, that can cause fouling, linger a spark and what have you. And you got to take those out. But again, those original plugs were drilled into the side, just like you alluded to a moment ago, and they were very poorly fit. So I don't think they shot as much power as we do today.